Hello guys, welcome back to Med Zone African Motives. Still on Mechanotechnics and 5 revisions. In this case, we shall be focusing on elevators. We have got the question paper of November 2022 in this case, where we just want to see some of the different techniques of answering this. But if you check the concept, there is just one and the same thing. All you just need is to know different types of questions as they do repeat. And I think we have seen that from N4, we have been seeing that happening. So question number 8, we are given the loaded cage in this case of goods hoist has a mass of 1,500 kgs. So this is a loaded cage. The rope passes over a drum at the top of the shaft and then to a balance of a mass 600 kgs and so forth. All right, so let us just try to have our typical information and just a diagram also. So this is our drum in this case, whereby we are given a loaded cage passing through this drum and being supported by a certain mass in this case. All right, so that is what we have in this case, our load going up, and here having our T2, T1. So this M1 is for our load in this case. So this is our loaded cage in this case. And the loaded cage has got a mass of 1,500. In this case, we are given that the loaded cage, a waste good of 1,500 kgs. So that is the mass M1, 1,500 kgs in this case. And we also given that as it passes over the drum to the top of the shaft and then to a balance mass, we are talking about the balance mass, which is the support balance of 600 kgs. So we are given the mass of the balance, which is this side, M2, which is 600 kgs. So M2 representing our balance in this case. So here we are referring to the balance mass or the balance support or the support balance. All right, then the cage and so we're given the cage and the balance mass moves in guides, and the frictional force at each guide is 500 Newton. So we're given the frictional force at each guide. So meaning to say the frictional force affecting both is going to be given as what? 500 Newton in this case. All right. Then what else? The drum has a diameter of 1.6 meters. In this case, a mass of 800 kgs. So this is the information that is affecting the drum. All right. So on the drum, what is it that we have? We are given the diameter of the drum in this case, which is the diameter of 1.6 meters. So from this diameter, we are going to obtain the radius, since the radius is diameter over 2. So if we divide 1.6 by 2, we are going to obtain 0.8. So that's our radius is going to be 0.8 meters. And also we are given the mass of the drum. In this case, if we check, we have the mass of the drum, which is 800 kgs. All right, so we've got the mass of the drum, which is 800 kgs. That's 800 kilograms. And also the radius of gyration, which is 0.5 meters. So this is the value of K, which is 0.5. So K is given as 0.5 in meters. It is supposed to be meters. And we also have, in this case, the maximum acceleration attained is 0.2 meters per square second, while the speed of, all right, so here we are given the velocity, which is the speed, all right, the speed, and okay, the first one is acceleration. Maximum acceleration is occurring at 2 meters per square second, and the velocity being at 2.8, that is our speed, in this case, velocity, that is at 2.8 meters per second. And also we are given take acceleration due to gravity. There we are given the gravitational acceleration to use, which is 10 meters per square second. So we are going to take our gravitational acceleration as 10 meters per square second. All right, so that is the whole information that we are given. And the first part of the question was to calculate the following 8.1, the tensions T1 and T2. So sometimes they do not ask these, they just ask us a particular question, calculate the total torque or this or that, but here they are specifying calculate the tension T1 and T2. So we've got T1 and T2 representing the tensions going up and the one that is going down. So it follows, I explained also on the formulas that you are supposed to be applying in this case. All right, so that is 8.1. So T1, which is the one that is going up in this case, is given. The actual formula was supposed to be M1. The one that is going up is supposed to be using M1 times gravitational acceleration, M1 times acceleration plus the frictional resistance in this case. So, but we are going to see that the mass here is the same. So you're just going to factor out M1 with remain with the G plus A plus the frictional force in this case. So that is the formula that you are supposed to simply understand or know from the one that is going up, T1. T2, the one that is going down, is simply going to carry a negative. And when it is accelerating, this acceleration is taken as a positive. So that is the whole part here. We're just going to substitute M1, which is 1,500 into G. We are given the G to use, which is 10, plus the acceleration, the linear acceleration of 2, plus the frictional force. In this case, we are given the frictional resistance of 500 Newton. So that is the whole part with our formula. I think everything is clear on this part. We're going to multiply. So that was going to give us 18,500 Newton in this case, or 18,5 kilonewton. So this is our T1. All right, then we move on to the second part. In this case, 8.2, we are now given. All right, so this is T1 and T2 at the same time. Sorry for that. So we need T1 and T2 at the same time. So let us calculate T2. So T2 is the one that is going down. So T2, the one that is going down, is given by the formula M2. Here we are just going to subtract. So it's going to be G minus A. Also the frictional resistance you subtract. So T2 is affected by M2, which is the mass of the balance in this case, which is 600. So we are going to use 600 kgs. So T2 is going to be 600 kgs into the gravitational acceleration. We are given that as 10 minus the acceleration, remember that is 2, minus the frictional force on both sides is taken as what? As 500. So here we are going to use the same frictional resistance. So that is going to give us T2 in this case. So T2, if we simplify properly here, we are going to obtain 4,300. That is the tension, 4,300 Newton in this case, or 4,3 kilonewton. So that is our tension 2. So that was our question 8.1. 8.2, the question is now to calculate the torque, the load, to hold dead load, and the torque to accelerate the drum. So we need the torque that is going to hold the dead load, that is T load in this case, the one that is affecting, or the one that is to accelerate the loads in this case. All right, and the one to accelerate the drum. All right, so we are going to need torque. All right, we are going to start with the torque to accelerate the drum, to accelerate the load in this case, that is to hold dead load in this case, to hold dead load. That is the one to accelerate the loads in this case, or the load in this case, right? To accelerate, there's just one C there, to accelerate. So what is the formula? So the formula there simply tells us that T load is going to be the difference between the tensions that we got T1 minus T2 times the radius of the drum. So we have T1 and T2. We calculated these ones, so we are just going to substitute in this case. So T load, that is T1 minus T2, T1, which is 18,500. So you're going to have 18,500 minus T2, which is 4,300 times the radius of the drum in meters. So you're going to take the radius of the drum in meters. All right, we listed somewhere, all right, the radius 0.8 from the diameter that we're given of 1.6 meters. So you put 0.8. So you're going to multiply by 0.8. So that is T load. Now we're talking about the torque. The T here, so we're supposed to use F, but because of the presentation of our syllabus, because this T is for the torque, then we've got the T for the tension, a force, a tension. So do not confuse on this part. All right. So this one is the torque that we are calculating, which is going to be 11,360 Newton meter. So that is the one to accelerate the loads in this case, that is All right, then we move on to the one to accelerate the drum in this case. So you're gonna need the one to accelerate the drum. So what is going to be the formula? So to accelerate, we are still on 8.2. We are still on the same information. So we're gonna need the torque to accelerate the drum in this case. So the torque to accelerate the drum in this case, to accelerate the drum in this case. All right. So the formula for the torque to accelerate the drum, which is T rho in this case, is supposed to be given by the moment of inertia times the angular acceleration. Then we add the frictional torque in this case. We are supposed to add the frictional torque when given in this case. So if we are to check, we are not given the frictional torque in this case. We do not have the frictional torque. So meaning to say our formula is going to be limited to the moment of inertia times what? The angular acceleration. So meaning to say here we are going to have our T rho given as the moment of inertia times the angular acceleration. We do not have this, but we have the formulas that correspond to the inertia in this case. Remember, inertia is mass times the radius of gyration squared. And we talk of the angular acceleration being the acceleration over the radius. So this one, we're going to use acceleration over the radius so that we are going to obtain, we use what we have in a linear because we do not have angular, but we have acceleration. We have the radius. In this case, we have K, we have the mass. So meaning to say we are going to use what we are given. We are going to change these formulas to the equivalent. All right. So meaning to say at the end, we are going to use our formula as T rho is equal to the moment of inertia. We say this one is mk squared times the angular acceleration, which is A over R acceleration over the radius. This is a conversion from angular velocity, from angular acceleration to linear, or a conversion that happens between the two. So if we are to write angular acceleration in terms of linear, it's the linear acceleration over the radius, which can also affect even velocity sometimes if you are given a conversion that need to happen. So this being the mass of the drum, this is being the radius of gyration of the drum, and the acceleration, the linear, and the radius of this is the actual radius of the drum. All right, so meaning to say our T rho is going to be the mass of the drum. We have everything on this part here, so we're just going to take on the drum. We said the mass of the drum is 800, K it's 0.5. So it's going to be 800 for the mass of the drum. That's going to be 800 times K 0.5, so it's going to be 0.5 squared times the acceleration over the radius. In this case, we are given the acceleration is 2, so that is the linear acceleration, 2 meters per square second. So we're going to have 2 over the radius of the drum. In this case, we are referring to the radius of the drum, that is 0.8. All right, so you're going to use 0.8 on this part. So this is over the radius, which is 0.8. So there we go. We obtain the torque that is affecting or that is accelerating the drum, which is T rho, which is going to be 500 Newton meter in this case. All right, so that was the whole concept of the question. So on 8.2, we wanted to calculate the torque to hold the dead load, which is to accelerate the load, and the one to accelerate the drum in this case. All right, so let us check other part of the question. Now the question is asking us on 8.3, the motor power required to drive the drum at maximum acceleration, the motor power that is required to drive the drum at maximum acceleration. Remember, we calculated at maximum acceleration these two torques that we have, the torque that is affecting the drum in this case. So it follows that in order for us to obtain the power, we are going to use the formula. The power to affect the motor is given as the total torque in this case times the angular velocity, which is the speed of the motor, which is the angular speed. But remember, I said if we are given anything in angular, anything that is in angular, it can be angular acceleration, angular velocity. You simply take what is in linear, divide by what? By the radius. So meaning to say, we are talking about angular velocity in this case. we are going to use linear velocity over the radius. The linear velocity over the radius is equal to this. So meaning to say our omega is simply the velocity over the radius, because we have the linear velocity on that information. So, but we do not have the total torque in this case. Where are we going to obtain the total torque? That is the sum of the two torques that we obtained before. So T total in this case is the sum of the torque that is affecting the load. So it's T load plus T drum, which is T rope in this case, the one that is affecting the drum. So we can calculate the total torque in this case because we have the torque that is affecting the load. Okay, all right, I listed them here. The load is 11,360. So you're gonna use 11,360 plus the torque to affect the drum, to accelerate the drum, which is T rope, which is 500 Newton meter. So there we obtained 500. So that is going to be the total torque in this case, which is going to be 11,860 Newton meter. So with this total torque that we are given, we are going to use it now to calculate the power of the motor. Remember, I said the power of the motor is going to be the total torque. In this case, that is T total. All right, multiplied to the angular velocity. But we said angular velocity in terms of linear velocity, it is going to be given as the linear velocity over the radius. So we're going to multiply to the linear velocity over the radius. So that means we are going to obtain the total power affecting the motor in this case. The total torque, we have it 11,860 multiplied to the velocity, which is the linear velocity over the radius. So we're talking about the linear velocity this time. Our linear velocity in meters per second in this case is given as 2,8. And remember, the radius here is 0,8. We are using the actual radius. So it's going to be 2,8 over 0,8. So that is the whole concept there. So you're going to use linear velocity. We say it's 2,8 meters per second over the radius, which was 0,8. So that's it. We are going to obtain the power that is affecting the motor in this case. So P motor is going to be something like 41,510 watts. So this is the power which is measured in watts in this case. So that was the whole concept. These are the typical questions. That is how they want you to play around this information. So you have to be very, very careful on this question. All right, let us check the other part of the question. Now we are given a consideration this time that that is on 8.4. We are given that the rope tension, we are supposed to calculate the rope tensions in this case, which is T1 and T2 again. But during deceleration, so we are now talking about a deceleration that is happening. If the maximum velocity is 4 meters per second and the deceleration is at a uniform rate from a maximum velocity to rest, meaning to say to rest, we are now talking about the final velocity being 0. Over the last 2 meters of travel, we are given the distance 2 meters in this case. All right, so this one we are going, let me just use even this part here so that I do not confuse you. Let me just use this part here so that we do not have any confusion. Remember, we calculated T1 and T2 before. Now we are supposed to calculate T1 and T2 on a condition of a deceleration. We are now talking about a condition of a deceleration that is happening. We are now talking about a condition of what? A deceleration. All right. So now there is a deceleration. In a condition of a deceleration, what does it simply mean? It simply means our acceleration is supposed to be a negative. It's supposed to be a negative value. If we are not given the acceleration, if we are to calculate the acceleration, we're supposed to get a negative. That is to show that this is a deceleration. It's a negative acceleration that is happening. So they are saying we are talking about the tension, which means we are supposed to calculate T1 again and to calculate T2 again, the same way we calculated before, but on a condition of a deceleration from a maximum velocity, which means from this velocity, which is now our initial velocity. So we are now having our initial velocity of 4 meters per second until it comes to rest with a uniform deceleration, meaning to say our final velocity is going to be 0 meters per second over the last 2 meters, meaning to say we are given the displacement, the distance over the last 2 meters. So that is the whole part of the question. So now it means we are supposed to calculate the same way that we calculated previously, but dealing with the deceleration. So what is going to be the our acceleration, which is the one that is supposed to be a negative. So given the displacement, the velocity, the final and the initial, we understand that 2as from our formula 2as is equal to v squared minus u squared. We can calculate acceleration divide by 2s, divide by 2s both sides. So meaning to say the acceleration can be taken as v squared minus u squared over 2s. So this is the formula that we're going to use now to calculate our acceleration. All right, so let us see what we are going to obtain. If we substitute our values, we are going to have final velocity v is at 0, so that's 0 squared minus u, which is 4 squared over 2 times the displacement of the distance traveled, which is 2. So as we can see, we are going to obtain a value of -4 meters per square second. This is to show that this is a deceleration, having a negative acceleration. In our actual sense, guys, this part here of calculating the tensions is not going to change. The formulas are still the same, only that the acceleration is now a negative. Remember the formula that we used to calculate T1. We said T1 is equal to M1 into G plus A plus the frictional force in this case. What just changed now is that the acceleration here is now a negative. That is the only part, because it's a deceleration. So it is going to be a negative. The formula is not going to change. So we are going to have our T1, the tension as before, which is M1, 1,500 into G plus A. So our gravitational acceleration is 10. But the acceleration now is a negative. So it is going to be plus then a minus of that acceleration. So plus and minus is going to give us a negative. We are already having this as a negative. So meaning to say we are going to obtain a minus at the end. So that's why we are saying for a deceleration, this is going to be a minus. It's not to say it's a minus, but it's because of the acceleration that is there, it's a negative. So if you just substitute that as a negative, still you get the same answer. So that is plus. We have our frictional force. Remember our frictional force, it was 500. So we are going to add 500. So that means we have got tension 1. So T1 is going to be 9,500 Newton in this case. That is our tension. So with the whole part or with the same information, remember how we calculated T2. We said T2 is simply going to be M2 into G minus A minus the frictional force in this case. So what is simply going to happen, because our acceleration is a negative, we are going to have a negative and a negative. So that is going to give us a positive. But in actual sense, this is the formula that we're supposed to have. So M2, that is 600 into G, which is 10 in this case. So you're supposed to have a negative, and our acceleration, it's a negative. So that's a negative, and a negative, guys, is going to give us what? A positive at the end. All right, then we subtract the frictional resistance in this case, which is 500. So you're going to subtract 500. So that's T2 is going to be negative, negative. Here is going to be a positive. So for a deceleration, this is going to be a positive. But you take a positive of what? Of that answer that you are given. All right, so that is the whole concept, guys. So this was going to give us 7,900 Newton in this case. All right, so that was our tension 2 in this case, which is the one going down. T1 is the one that is going up. T2 is the one that is going down, but it's just affected because it's a deceleration. Instead of having normal a positive value for acceleration, our acceleration is going to be a negative. That is the whole concept when we are talking about a deceleration. And also to understand your calculations, if you are not given acceleration like this part, we are supposed to use our formulas for linear motion, because we are given these from our linear. So you can use formulas. V squared is equal to U squared plus 2AS. If it is maybe a given time, V is equal to U plus AT. depending with which formula is applicable, you get S is equal to UT plus half AT squared. It's going to depend with which formula are you given. So, but just relate from your formulas of linear motion, you pick the best formula that suits where there is acceleration. So in this case, we could have used this one. 2s is equal to v squared minus 2s to make acceleration the subject. You calculate that because it's a deceleration, we are going to get a negative answer. So that is the whole concept of elevators. You see different questions, but they just change values, but the concept is one and the same. The concept there is simply one and the same. So let us revise as many questions as we can as we prepare for exams that are ahead of time.